Okay, after you've watched some of the videos on how to solve limits numerically, this kind of should be the next video that you watch just to get a little bit more of an idea on this concept of the limit. So I've got some function here graphed out. Now we don't really care what the actual function, how it's defined, other than I just want you to look at the graph. And let's take a look at where I've got these hash marks here on the x-axis, these red marks. And I just want to say that if we were taking the limit of some function, which you can see the graph of our function here, as x approaches whatever this is going to be negative 10 for example. Does the limit exist at negative 10? And the question is yes, the limit does exist here. Now you notice this is a hole in the graph, and so the limit is going to exist at a hole, loosely speaking. Okay, and of course the limit's going to exist. If you notice this graph here, there's no holes or breaks in it. We're going from this hash mark to this hash mark here. You can see this is known as the graph is continuous. Okay, no holes or breaks in the graph. Now what about as x approaches 0? The limit of our function as x approaches 0, well, this black dot here is indicating that it's nothing more than just a point on the graph. So the white dot indicates there's a hole in the graph. That's just a point on the graph. So the limit does exist at this, and it's equal to some real number also. And this up here could be, for example, 20. Anyway, so the limit exists here. The limit exists here. Now let's take a look at this one here. And of course the limit exists here. This is just a point on the graph. But what about this point right here on the x-axis? Well, coming in from the left-hand side, remember the left-handed limit, you would pick a point somewhere to the left, go up, right? And as we get closer and closer to this mark here on the x-axis coming in from the left, my y value you can see is getting closer and closer to, well, I don't know, whatever this is right here. But the left-hand limit exists, and it's whatever the y value is associated with, for example, this hole in the graph. We come straight across and look at the y value. Right? But if we looked over here on the right-hand side, coming in from the right-hand side, we would go straight up, and here's our graph. And as we got closer and closer from the right-hand side, okay, you would see, right, it's staying constant, but the y value is something up here. I think I called this 20 earlier, whatever. But you see coming in from the right-hand side, the limit is not equal to the limit coming in from the left-hand side. So you see where the graph is broken right here, the limit does not exist. All right, let's take a look at another example. Okay, so this is another possibility. So we've got our hash mark here. This is our C, as in the definition of the limit, right? And if we come in from the right-hand side, you can see that the graph is going up to positive infinity. Now our limit must be equal to a real number. So we can see right away that this limit does not exist, right, at this particular point here on the x-axis. And coming in from the left-hand side, right, it's also going up to positive infinity because we've got this vertical asymptote here. So the limit doesn't exist, but we could denote that the limit of our function as x approaches whatever this number possibly could be. We could say it's 5 right here, but we could denote that it is going to positive infinity. It just tells us what the behavior of the graph is doing as we approach, for example, 5 here. But the limit technically does not exist. However, we could state it that it is going to positive infinity, right, coming in from right and coming in from the left-hand side.